Welcome back to Nick's Algebraics. So in my last video, I was talking about how to write equations, but today we're going to talk about how to solve some basic one-step equations. So before we get into that, let's talk about what a linear equation in one variable is. It's an equation that can be written in the form of ax plus b equals 0, where a and b are constants and a does not equal 0. Because if a equals 0, then you'd just be left with b equals 0. And when I say solve an equation, that means to find the value of the variable that makes the equation true. So if you get something like x plus 1 equals 2, when I say solve the equation, I'm saying what value of x would make this true? And the solution is the value that makes the equation true. So the solution in this case would be 1. So solving means you're finding the value, and that value that you found is called the solution. And we're going to use inverse operations, which are two operations that undo each other, such as addition and subtraction or multiplication and division. They undo each other. And when you perform the same inverse operation on each side of an equation, you produce equivalent equations, which are equations that have the same solution or solutions. So an example of this would be like x plus 2 equals 4. So the solution to this would be 2 because 2 plus 2 is 4. And you could also say that in the equation x plus 3 equals 5, the solution is also 2 here. So these are equivalent equations because they have the same solution. So we've been talking about a lot of properties in the past videos. So the addition property of equality says that if an equation is true, adding the same number to both sides of an equation produces an equivalent equation. So what that means is that if I have a equals b, I could add some number to both sides, like c. So I could add c to both sides, and it'll still be true. So for example, if I have 5 equals 5, I could add 2 to both sides, and it's still true. So let's use this property to solve some equations. So x minus 3 equals negative 5. So we want to end up with x equals some number. We want to isolate x and just keep it on its own. So to do that, we have to get rid of this negative 3. And to get rid of subtraction, we use addition. Because if I add 3 to both sides, then negative 3 plus 3, that cancels out. So you're left with x equals negative 5 plus 3. And negative 5 plus 3 is negative 2. And you might be wondering, how do I know if my answer is correct? How can I check my work? So to check your work, we could substitute negative 2 for x. So you could write negative 2 minus 3 equals negative 5. Because instead of x, I just wrote negative 2 here because they're the same thing. And then you could evaluate. So negative 2 minus 3 is negative 5. And you get negative 5 equals negative 5, which is true. So you know that your answer is right. If you got something like 0 equals 1, then you know that your solution is wrong, that you did something wrong. Let's do another example. C minus 22 equals 54. So we're trying to get C on itself. So to do that, we have to get rid of this negative 22. And we're going to use the addition property of equality to do that. So we're going to add the opposite of negative 22 to both sides, which is positive 22. So negative 22 plus 22, that cancels out, that's 0. And we're left with C equals 54 plus 22. And 54 plus 22 is 76. And let's check our work by substituting 76 for C. So instead of C, I'm going to write 76 now. Minus 22 equals 54. And 76 minus 22 is 54. So you're left with 54 equals 54, which is true, so we know that we did it right. Now here's another property that can help you. It's called the subtraction property of equality, which is similar to the addition property of equality, except you're subtracting. So if an equation is true, subtracting the same number to both sides of an equation produces an equivalent equation. So if you have A equals B, you could subtract C from both sides, and that'll produce an equivalent equation. So if we have 5 equals 5, I could subtract 2 from both sides, and you'll get 3 equals 3, which is true. So let's do an example. 63 plus m equals 79. So we're trying to get m on its own. So to do that, we have to get rid of this positive 63. And to cancel out 63, we have to subtract 63. And what we do to one side, we have to do to the other side. So 63 minus 63 is 0, so it cancels out. So you're left with m equals 79 minus 63. And 79 minus 63 is 16. So we get m equals 16. And let's plug in 16 to see if our answer is correct. So 63 plus 16 equals 79. And 63 plus 16, that's 79. So you're left with 79 equals 79, which is true, so our solution is correct. So let's do one with decimals. So 0.9 equals y plus 2.8. So to get y on its own, we have to get rid of that 2.8. So we can subtract 2.8 from both sides. So 2.8 minus 2.8 cancels out, and you're left with 0.9 minus 2.8 equals y. And 0.9 minus 2.8 is negative 1.9 equals y. And you could also write that as y equals negative 1.9. So let's substitute negative 1.9 for y. So 0.9 equals negative 1.9 plus 2.8. So negative 1.9 plus 2.8 is 0.9. So you're left with 0.9 equals 0.9, which is true. So our solution is correct. So now let's talk about the multiplication property of equality. So that says that if an equation is true, multiplying the same non-zero number to both sides of an equation produces an equivalent equation. So if I have A equals B, I can multiply C to both sides to get this equivalent equation. And C is a non-zero number, so C does not equal 0. Because if C is 0, then you'll be left with 0 equals 0, which is not helpful. So if we have 5 equals 5. I can multiply 2 to both sides, and you'll get 10 equals 10, which is true. So let's use this to solve this equation. Negative n over 5 equals negative 3. So we're dividing by negative 5. And remember, multiplication and division are inverse operations. So we're going to use the multiplication property of equality to get rid of that negative 5 that we're dividing by. So we can multiply by negative 5 on both sides. So negative 5 and negative 5 cancel out because negative 5 over negative 5 is 1, and 1 times n is n. And what we do to one side, we have to do to the other side. So negative 3 times negative 5 is 15. And now let's check our work. So 15 over 5, negative of that. So 15 over 5 is 3, and we drop the negative. So negative 3 equals negative 3, which is true. So 2/3 q equals 1/2. So to cancel out the 2/3, we can use the reciprocal, which is 3 over 2. And the 3 and the 3 and the 2 and the 2 would cancel out. And we could also do it to this side as well. So we're left with q equals 1 times 3, which is 3, and 2 times 2, which is 4. So you get q equals 3 over 4. So let's plug it in. So 2/3 times 3/4 equals 1/2. So 2 times 3 is 6, and 3 times 4 is 12. And 6/12, so you could divide by 6 on both sides. So you get 1 over 2 equals 1 over 2. So that's true. Now let's talk about the division property of equality. So that says that if an equation is true, dividing the same non-zero number to both sides of an equation produces an equivalent equation. So if A equals B, I could divide by C on both sides to produce this equivalent equation. And C is a non-zero number because you can't divide by 0. So if I have 5 equals 5, I could divide both sides by 5, and you'll get 1 equals 1. So let's use this to solve this equation. 39 equals negative 3r. So we're multiplying by negative 3, and to cancel out multiplication, we have to divide by negative 3. So negative 3 over negative 3 is 1. So you're left with r equals 39 over negative 3. And 39 over negative 3 is negative 13. So let's plug it in. So 39 equals negative 3 times negative 13. So negative 3 times negative 13 is 39, and 39 equals 39, which is true. So let's do this one. 1.3z equals 5.2. So we're multiplying by 1.3, so let's divide by 1.3 to cancel it out. So you're left with z equals 5.2 divided by 1.3. And 5.2 divided by 1.3 is 4. Let's plug this in. 1.3 times 4 equals 5.2. And 1.3 times 4 is 5.2, so you're left with 5.2 equals 5.2. So I'll be posting a worksheet with the solution in the description below. And don't forget to subscribe, like the video, turn on your notifications, and comment down below. I will see you soon.